Okay, so I would like you to go ahead and don't graph this yet. We're going to graph it together, but please write down this piecewise function. Okay, so a piecewise function is a function that is made up of different pieces of multiple equations. Okay, so here we have a piecewise function made up of 3 pieces. Okay, thank you. Yep. Okay, I need someone to describe to me what these are referring to right here. The limits of the what? The domain. Okay, so these are the domain restrictions for these pieces. Okay, so we really only want the line negative 2x minus 1 when x is less than negative 2. Okay, so where do we start? Do we know what the line negative 2x minus 1 looks like? Yes, we do. Okay. However, we need it to begin at negative 2. So what will be the coordinate on the line when x is negative 2? Yeah, 3. Okay, and what would go at the coordinate negative 2, 3? An open circle. Because we do not want to include negative 2. Okay, and we know that this line has slope of negative 2, so we know that it needs to fall. Okay. So there's that piece of line. Okay, so how about you draw in for me this line from negative 2 to 2? What would that look like? So x is negative 2 would mean y is negative 2, right? All the way up until when x is 2, y is 2, but we would have an open circle there. So this is the line, y equals x, but we only want it from 2, negative 2 to 2, but we don't want to include 2. And then the line 2x minus 3, do we know what that looks like? Okay. Even if we don't, but even if we didn't, we know that it starts at 2. So if we plug x equals 2 in, what would our output be? Okay. And then you could plug in 3, and then you could plug in 4, and then you could plug in 5. But we're sophisticated because we're in calculus. We know that this is a line with slope of 2. So we know it's going to look like that. In your extra practice homework tonight, I have a piece-wise graph for you to draw. It's probably been 11 months since you've drawn a piece-wise graph, so let me make sure that we talked about it and you practice it tonight. It is okay if 2 pieces overlap, like if you have an open circle overlapping with a closed circle from 2 different pieces, that's fine, we fill each other in. We still have a domain of all real numbers, okay, and it's still a function. Okay. Well, what if I asked you to evaluate here? And so really, I don't need. Same piecewise function, but we're going to evaluate these 3. Okay, so if you want to go ahead and write those down. You know what? I'm going to have you answer them together at your pod, and then we'll try to answer together. How's that? So these 3, I want you to answer together at your pod, work on them, and then we'll come back and talk about what the answers are. F of 1 has 1 answer. Where would you plug 1 into? Right, but okay, so there's 3 different pieces, right? But each piece has a specific domain, right? So if X is 1, this would be.
So you plug in. So you take the.
Each has only 1 answer. The answer is a number. So X is 1. So that answer you're finding the Y value. So it's just 1 number. 1 number is your answer. Just 1 number. Well, there's 3 pieces, right? 3 is there. Figure out 1 piece. So it's X is 1. Okay, so X is 1. Where is that fitting?
So is he like fine to it? I'm not doing it. Yeah.
All right. Let's come all together. Ethan, what's f of 1? F of 1 is 1. Okay, something that some of us had to wrap our minds around. Okay, we have 3 different pieces, right? But each one has a specific domain. So x equals 1 only fits into one piece. It fits into this piece right here. So we're going to take 1 and we're going to plug it in here. Okay? F of 2. Finley, what does f of 2 equal? Also 1. 2 fits into this piece here. If we plug in 2 to this piece, 2x minus 3, we get 1. F of 3. Okay? Work from the inside out. First, Xander, what is f of 3? Really? F of 3 is 3. So this piece right here, if we plug in 3, we get 3. So we have f of 3, which is, that was kind of a boring one, wasn't it? I didn't choose very well. It was exciting because it was the same. It wasn't boring. Okay. Are there, what questions do you have on piecewise functions? All right, let's work with our calculator. Now, if you haven't touched your calculator since, yes, you can borrow. If you need to check one out, we'll talk after class. We can borrow one for today. It's so far.
So much like.
We can run across this office here, but we can't. Okay. Make sure that you are in function mode. My
Yeah, this one's kind of like it. This is full. Wow.
Oh, they weren't actually all the way in. There we go. Okay, so they weren't actually charged up, huh? All right. Make sure you're in function mode. Mine was in parametric mode when I grabbed it out of my bag, so I don't know if that was from calculus or pre-calc, but make sure you're in function mode. And yes, make sure you're in radian mode, because if you graph any sort of trig function, it needs to be in radian mode. So go ahead and graph this. Go ahead and put this in y equals for me. We're going to find the zeros. So I'll get my handy dandy calculator here. Huh? Fair enough. X to the 4th. Minus x cubed.
You said this is in degrees.
You want your calculator to be in radians. Right now it's not going to matter, but if we were to put a trig function in there, we would want radians.
So is it okay if instead of x, I have theta?
So you need to be in function mode. You're not in function mode.
Yeah.
Okay, you have a stack going on. So, and go ahead and when it's done thinking, go zoom 6 so it's back in the next. Okay, a couple things about your calculator. If yours doesn't look like mine, you're not in like the standard window. So zoom 6 will always get you back to the 10 by 10. How many of you are in stats? Wow. When you're in y equals, do you see these plots? If any of these are highlighted, it will not graph for you. So those of you who are switching back from calc to stats, make sure you turn your plots off when you come in here to graph. If you ever have an issue where you're like, I know I typed everything in right, but it's not graphing for me, go here and make sure that these are not highlighted. If they are, just click them off, okay? All right. Does everybody have a graph that looks like this? Okay, so do you remember when I said put it in function mode? It was not in function mode.
Yeah.
Yes.
I like PreCalcRev. I just put dots. Okay. All along the bottom.
All right, so the first thing we're going to do is find zeros. This is something that I did teach you in pre-calc. If you were in my class or Miss Cronky taught you in her class, but you probably don't remember, okay? So, do you see this trace button right here? What does it say above it? Okay, the other one, count, okay? This is going to be your best friend. This menu is your best friend. So, if you go to second, trace, which is the calculate menu. I want to find zeros. Which option should I pick? Okay, so you can either arrow down and hit enter, or you can just select with the number, but it's going to ask you for a left bound. So everybody, eyes up here. I am going to find this zero right here. And if it's asking me for a left bound, then I need to get that blinky cursor somewhere to the left of that zero. Is that to the left of the intersection? So I'm going to hit enter. Now it's asking for a right bound. So I'm going to get my blinky cursor to the right of that intersection. And then it asks, do you want me to guess? Enter. And then it will give you the zero. Go ahead and try that. As long as when it's asking for the left, it's to the left. When it's asking for the right, it's to the right. That's all that matters. Okay. Are you getting negative 1.44, blah, 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 blah?
Wait, how do you go back?
So, second calculate. Oh, it's asking for the. Okay, there are 1, 2, 3, 4 zeros. So we found one together. Find the other 3 real quick. Find the other 3. until you find a different letter. Left is asking for left then. Of this up here? Okay, so that's not that's a minimum. A little confusing. Okay. I mean, if you were doing a minimum, that would be. Okay. Back to here. So 2 can anything with any adult. And so it's like sometimes like our calculator is approximate, so every once in a while we'll do that, or you'll have like 1.99999. That happens for anybody else. Is it a double version?
Yeah, I'm doubling it. I don't know why it happens, but I see like. Second lunch. Yeah. 2 signing on the other.
He personally wants to go to lunch.
We're good here? Are you going to need to turn down a calculator?
No, it's just one Alright, well,
Allie, are you going to? Yes.
All right.
So we're gonna have to find those words. Well, you want more versions. I know I saw that. He said, I wrote you. I said, where's the invite?
I put it's like a cell phone, but
So is it 7:30?
yeah.
Okay. All right. One more thing on your calculator, and then we'll talk about this summer packet. Okay. The second thing you need to be able to do to be helpful in the once we get into the calculus is finding the intersection of two graphs. Now, yes, we could set two equations equal to each other and solve, but do you want to solve for, well, this one's actually not so bad, but if we had like a cubic equal to a 4th degree, you don't really want to solve that, okay? So sometimes it's going to be easier, more efficient to use our calculator. So if I want the intersection of these two graphs, then first of all, we would want to graph them. So go ahead and put these two functions into your graphing calculator. X squared minus 4 and 2x minus 1. X squared minus 4 and 2x minus 1. Okay. This is something that's going to be very helpful once we get into like some of the like when we get into our calculator work with calculus, it's going to save us a lot of time. Okay. So this is what our graph looks like. We could find this without a calculator, I know. Okay. But we also could find it with a calculator. So in that calculate menu, that second trace, do you see the option that we need? Intersect, number 5. And guess what? All you need to do is go to whichever intersection you want to find. First curve, enter. Second curve, enter. Guess, enter. Just put that cursor over the intersection and hit enter 3 times, and it'll give you the coordinate. -1, -3. Okay? Find the other one also. Just put that cursor over where they intersect and hit enter 3 times. Okay, so if you want some extra practice on the 3 things that we just went over, you can do these problems. If you don't want extra practice, I'll never know. Yes, this is all. Okay. Also, I want to show you, anytime I hand out something and we have extras, I will put them right here in this green folder so that if you're gone or you lose one, you can come right here without even having to ask me where they are. Okay? All right, I'm going to go and stop this.